Hello everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events. This event is one of such events. If you want to find out more about the events we have, there is a link in the description. Go there, click on this link, and you will see all the events we have in our pipeline. And of course, now you're watching this on YouTube, please subscribe to our YouTube channel. This way you will stay up to date with all the videos, all the streams we have on our channel. Last but not least, we have an amazing Slack community. If you haven't joined it yet, it's time to do this. You will get a chance to talk to other data enthusiasts there. During today's interview, you can ask any question you want. There is a pinned link in the live chat. Click on this link, ask your question, and I will be covering these questions during the interview. So I think that's all I have. So now I will need to open the questions. Okay, I have the questions now. I think I'm ready. Are you?
Yeah, I am. Let's go.
Okay. This week we'll talk about transitioning from data science to data engineering. And we have a special guest today, Ellen. Ellen is the head of data engineering at Where Is My Transport, which is a company that provides mobility and location data for emerging markets. She has been working in software engineering, data science, and data engineering roles for over a decade. And a common theme across her career is her passion for building high-quality technology, of which data is a core component. She also enjoys teaching, speaking, and writing about data topics. Welcome, Ellen.
Thank you. I'm happy to be here.
Yeah, happy to have you. So before we go into our main topic of transitioning to data engineering, let's start with your background. Can you tell us about your career journey so far?
Of course I can. So I studied computer science in uni. That was my first degree, and I really enjoyed it. And I specialized in software engineering and what's called in German Wirtschaftsinformatik, which translates to like business applications of computer science. And then I worked as a software engineer for a bit in different countries. And then I got really bored with backend engineering because I felt I was building the same kind of read data from a database, put it into an API and get data from an API and put it back into the database thing for over and over. And at the same time, I started a psychology part-time degree, and I didn't really enjoy the psychology part that much, but I was really surprised that I really enjoyed the statistics course that is obligatory for psychologists. And then at that time, that was when data science became a bit of a hype topic. And I thought, hey, maybe that's a cool way to combine my interest in technology and in statistics. And so I set out on a path to become a data scientist. I did a Udacity nano degree, which is kind of an online bootcamp to level up in machine learning and a bunch of other online courses. And then I got a job in a data team, in an insights team at SoundCloud. And yeah, I had a pretty broad range of things. I did everything from data pipelines and scheduling. SoundCloud at the time had its own data scheduler. But also I did a lot of predictive analytics stuff and plain old dashboarding and everything that's in between there. And that's where I officially earned the title of data scientist or senior data scientist. And then SoundCloud had a massive round of layoffs that was quite painful to me because I really enjoyed working there in 2017. And then I worked as a data scientist in a few other companies, doing, again, predictive analytics, dashboarding, but also doing production level modeling. So everything in between. But I realized I didn't really enjoy data science as much because it was very black boxy, it felt to me, because I felt like I was feeding some model, but I didn't really understand what was going on, which is partially due to the fact that my mathematics background isn't that strong. So I never really got the theory behind it. But also I realized I kind of miss more the engineering part of it. And that was also the time when data engineering became more of a thing, because companies realized that they need not just data scientists, but also people that actually come before them and make data available for data science, because at the time was a common frustration for data scientists to not have data. Great ambitions, but no data. And then I went got an offer at Native Instruments to be one of their first data engineers. I did that for a while. I still had the ambition back then to transition back into data science, but I left Native Instruments for unrelated reasons before that happened. Then I got another job at another company as a BI developer. My title was data scientist, but really what I did was develop custom data visualizations. And I realized eventually that this was kind of a dead end for me. And so I remembered my software engineering background, which I actually enjoyed, except that it was so repetitive. And then at the time I was speaking to somebody at ThoughtWorks. She was the first data scientist at the ThoughtWorks in Germany at the time. And she told me that ThoughtWorks was planning to expand its data engineering offering and whether I'd be interested in becoming the ThoughtWorks Germany's first data engineer and help her expand that offering. And I thought it was really exciting. And especially since ThoughtWorks is a great place for really learning good software engineering practices, which as a data engineer has always frustrated, as a data scientist has always frustrated me that the quality of the code and the collaboration wasn't as good as I remembered it from my backend engineering days. And so I jumped on that, and that's when I finally decided to stay in data engineering, which I had done on and off before. And then after ThoughtWorks, I went to where I'm now at Where's My Transport and built up data engineering there, where I'm now heading a team.
That's quite a story. Thanks for sharing. So what I also wanted to ask you, the next question I prepared is that you were a data scientist and then you switched to data engineering. And I wanted to ask why. I think you partly answered that. So you said that data science was a bit too black boxy for you, right? So you wanted to understand the theory right behind this. You also mentioned, at work you don't really need to know this theory, right? So you have an algorithm, you feed some data, you get out of the model, and then you spend most of the time, I guess, doing other things. So you don't really focus on that, the ML part, machine learning part. And then you also mentioned another thing, that as a data scientist, the code that you were writing wasn't really high quality, right? This is something that maybe because this is not the focus for data scientists, so you focus on other things. Were there other reasons why for you it was clear, okay, data science is not for me, I want to go more in data engineering?
Yeah, those were two of the main reasons, but there was another reason which I realized is, at least at the time I was trying to be a data scientist, if you didn't work in a large company, like maybe OLX or Zalando or one of the really big Berlin companies, the roles of data scientists were pretty frustrating. I never wanted to work in such a large company. And then if you start up a data science department, you usually just stuck doing a lot of really drudgery work. And I got tired of that. And in a lot of companies, and that's a sad truth, engineering is more respected than data science, except for those that really focus on data science. And so I realized that whenever I did more data engineering work, I had a more comfortable working environment. And my skills were more in demand, and I didn't have to fight so much for getting anything, for proposing ideas and things like that. And so it was also a question of kind of professional respect for me that I was more comfortable with the environment that I was experiencing as a data engineer than as a data scientist.
Oh, that's an interesting point. I didn't hear about this in Zalando or OLX or other companies here in Berlin, but I did hear that a lot from big tech companies like this funk, like Amazon, Facebook, which is Meta now, Google, that a data scientist there is, as you said, that engineers are more respected, so to say. That's also I heard only anecdotal evidence of that. So people would tell me that engineers are like first-class citizens, while data scientists aren't. So I'm quite surprised to hear that, to be honest. But I guess since many people mention that, this becomes a pattern, which is pretty sad.
It is sad, I don't think it should be that way at all, but it is. Unfortunately, I've experienced it in quite a few places.
And but as a data engineer, I guess as a data scientist, you already needed to do some things that data engineers would do, right? So you mentioned
Yes.
that at SoundCloud, so you not only did modeling, but also everything that was before modeling, like building data pipelines,
Exactly.
and after modeling, I guess, deploying the model. So how does it overlap with what data engineers usually do, what you did as a data scientist?
There's a lot of overlap, and so as a data scientist, usually or often you don't work with perfectly clean and perfectly delivered data. You will still build up your own pipelines to make the data accessible, and especially if you move into more production level. And I mean, the data science is a very loose title, and what you do under this role can be very different. But there's often a lot of pipelining work that you do on yourself, and I think it's a good thing that data scientists do that and don't just rely on data engineers to kind of handhold them through these steps. And so there's a lot of transferable skills. It also depends also data engineering is a very broad topic, and I never did the more Kafka real-time data engineering kind of stuff. I've carefully navigated myself around that. I've always done more what is now considered analytics engineering, maybe, which is more like the preparing data for BI and data warehouses and scheduling, batch processing, and all these kind of things. So that was more my realm of data engineering. And there's this whole other universe of data engineering that I've never really touched, and that I don't feel, I think, where you need a better understanding of distributed system and things like that, which I don't have. And so that is often more the playground for people with a really strong distributed computer science background. And that isn't just not my realm. But for anything that's more in the realm of what is now analytics engineering, that kind of branch of data engineering, I think data scientists are really well prepared. There's obviously things we need to learn, but there's a lot. I've often found that people that come from pure software engineering and don't have a feeling for data, that they struggle more to move into that space than people that have a data science background and just need to level up on software engineering and collaboration skills.
What is this feeling of data, in your opinion? What is that?
Yeah, that means understanding. It's a lot of things about data. So data, as you know, I don't have to tell you, is very complex. So it has all these, how it's produced, all the quirks it has, the statistical aspects of it, understanding what the data actually means, how it's structured, how it evolves. And for a software engineer, and I remember that from my software engineering, data is often just something that we don't really worry about. It's just something we pipe in and out, but we don't really worry what it is and where it comes
some
from.
JSON, right? So some JSON or XML file, you just get it. You do something with this and then you spit it out, and then something happens after that, right?
But the big part of data engineering is really worrying about the quality of your data. That's probably the biggest chunk. And for that, data science, that's something that data scientists are very familiar with, data quality issues and how to deal with them and what to do about them, and having these conversations around with the people that collect the data, produce the data, and all these kind of things.
But you also mentioned that you were doing more work of what is called today analytics engineer, rather than Kafka distributed system kind of data engineer. So do you think this worrying about data quality applies to all data engineers, regardless of whether they work with distributed system or more like with DBT kind of tools?
I think it applies to everyone, because data quality are just a thing of data. I mean, data always has quality issues. You can't avoid that. I think it's just the extent of that people worry about it is different. So I hear less, and maybe it's because I'm not that in tune with that community, but I hear less concerns about data quality from the distributed systems crowd than I hear from the analytics engineering crowd. But data quality issues are just a fact of life. You have to deal with them.
So if to summarize, the skills that are transferable from data science to data engineering are, this pipeline building thing. So you need to prepare your model, all the data that before you can put it in the model. So you need to have a data pipeline. So that part, then also this feeling of data, right? Knowing the data is not just a simple JSON. Is there something more?
Yeah, generally the whole explorative and communicative approach. So data scientists have to work really closely with their stakeholders, usually in various business domains, and that is super important as a data engineer as well, because you never produce the data for yourself, and you never produce it for, you always get it from somewhere, you produce it for somebody, and talking with both the producers and the data consumers is really key, and being able to understand what they need, and even if they don't know exactly what they need or why they're producing the data and how they're producing the data.
Okay, so pipeline building, understanding the feeling, getting the feeling of data, and then the stakeholder management and communication. Yeah. But what were the things that you needed to upskill yourself or learn for making the transition? So one thing you mentioned is, as a data scientist, you didn't care that much. Well, it wasn't the focus for you, and for most of the data scientists, it's not the focus to produce good quality code, right? So I guess that was one of the areas that you needed to upskill yourself, right? Were there other areas?
Yeah, there were two more other areas that I think are really important. One is the whole idea of collaborating with other engineers. There's a whole amount of tooling like version control and build CI pipelines and all these kind of tools that software engineers usually use to collaborate together to make sure that when they work in larger teams, that the code still runs, still is tested properly, and it doesn't break and can be restored if one of them makes a mistake, and that they catch mistakes and all these kind of things. So there's a whole, that usually as a data scientist, and it's very common for us to work alone in our own Jupyter notebooks or whatever we may be using. And this whole collaboration around like making sure that your team that you can work with your team members in a reliable and efficient way. That's something I had to learn. So that the whole tools around it, but it's also a mentality around pairing and code reviews and things that data scientists sometimes talk about and sometimes are aspirational, but aren't that much part of the daily practice. And that's also where to me, the whole clean code and quality code is just an aspect of that, because you don't write it as an end to itself just to make your code really beautiful so you can put it in a frame on the wall, but it's really to help your colleagues understand what you've been thinking about when you wrote that code. And the other thing is the whole how to deploy things, the whole DevOps aspect of data engineering, which is pretty strong actually. How to deploy things, how to spin up and shut down servers or Airflow clusters or whatever you might need, a Kubernetes pod. So dealing with the whole cloud infrastructure and in an efficient way, and not just by poking around in the UI, but also by automating things efficiently. That is the other thing that I really had to learn. And that was my least favorite part initially, but now I enjoy it.
Yeah, this poking the UI part is very close to my heart as a data scientist, because what we are trying to do is at Relix, we're trying to educate data scientists to use things like Terraform.
Exactly.
Right, and yeah, it's always easier just to go there, click buttons in AWS console, and then you have I don't know, your Lambda function or whatever.
Yeah.
But then people who need to look after the infrastructure, after the AWS account, they always come and say, hey, what are you doing here? Why do you do this? Because like they don't have any visibility into what's going on.
Exactly.
So do you think for data scientists, people who do not plan to switch to data engineering in the nearest future, do you think it's also useful to learn the skills like CI/CD, testing, infrastructure as code, automation, and all these things? Do you think it's useful for them, or it's not it shouldn't be their focus?
I mean, I think the data scientist role is a bit bifurcating right now. And so there's more the ML engineering and MLOps and all these new fancy titles that are springing up. And for everybody who wants to work more in this building production service, ML, that is definitely really important to understand how to do monitoring, how to do infrastructure automation and testable infrastructure, and all these kind of things are really, really, really important if you want to have anything in production, because if it's in production, it has to meet the quality standards of everything that else it's in production. It can't, the ML service can't be the weak link in your e-commerce or whatever infrastructure you have. But if you really want to stay in the more research focused thing where all you do is prototyping, which I guess still exists, I'm not sure. It's becoming less and less common to have these kind of data science roles where you're really just putting prototypes or visualizations. And I guess you don't need to, but I think the trend is moving more into it's really valuable to have these skills kind of direction.
Yeah, what we see that data science, like this part of modeling is only a small part, right? But you have like a vast a vast thing before that. Okay, how do you prepare data? And
Yeah.
then a vast thing after you train the model, like how do you go about deploying this?
Exactly.
And the modeling part is only like a couple of % of the actual work. So that's why we have ML engineers and data engineers to help data scientists take care of that.
Yeah.
Yeah, interesting. And like, how did you actually pick up these skills? Did you just learn by doing projects, or did you learn it at work, or you needed to take some courses? How did you learn the CI/CD and other things?
I mostly learned it at work. I was lucky to at both of Native Instruments and at ThoughtWorks to work with really talented people. And ThoughtWorks in particular has a really strong culture around engineering practices, so I picked up a lot there. But also at Native Instruments, I had a colleague who was really dedicated to these kind of practices and brought a lot of this into our team. And so, yeah, I was fortunate to learn this. But I think back then also, when I moved into data engineering, there weren't that many courses around these topics. So it was also kind of a necessity to learn it at work. But I think nowadays, it's if you have the chance to take one of those courses. So I know our data engineer in my team, she's currently taking the data engineering bootcamp that you're organizing.
Cool.
And so I think that's really opportunities like that are really helpful actually for people to pick up these skills in a more organized fashion and not just rely on the lucky or unlucky coincidence that your colleagues can help you.
But do you know how does it usually happen? So yes, indeed, we don't have a lot of materials like for data science. For data science, we've had courses for quite a while, right? For 5 or more years. For data engineering, this is still emerging. So do you think if a data scientist wants to become a data engineer, they already have enough skills to get a job as a data engineer, or they need to upskill themselves before they can get a job?
It's very individual. I've seen data scientists that are brilliant at and really pick up software engineering and DevOps really quickly. And I've seen people that really struggle with that. And I think that's highly individual. And I think it's also, I would always recommend to try it first, also before you make a big career transition, to figure out if you really want to go in that direction. So I think it's always helpful to do a side project or try it out at work in a small context where you can, before you decide that you really want to change your career. That's a mistake I've made actually sometimes, to switch roles too quickly and then realize it wasn't for me. And
was it data science?
Yeah, exactly. That was for me a bit of a dead end, and I probably could have figured that out earlier, but I didn't. And so I would recommend for people to try out, if they consider a new role more attractive, to really jump into it without maybe switching their entire job.
Probably for data scientists, at least for most data scientists, you have a way to actually try this, because you need to take care of data preparation, right?
Exactly.
Even if you have data engineers in your team, you still need, like, this still needs to happen, right? And maybe you can just work closer with data engineers and learn from them, and then realize that this is indeed for you. And only then decide to transition to data engineering full time.
Exactly, and maybe then also invest more fully into like formalized training or courses or something like that. I think that's the best part, to just try it out by expanding your scope at work a little bit and seeing if it's for you and how comfortable you are and how much joy it brings you.
I see two major ways and two major, let's say, like for people who want to get into data science, they usually either come from a more mathematical background, so maybe they have a PhD in physics, or you know what I'm talking about, like they are maybe coming from academia. And then there is another kind of way, is people who are software engineers and they get into data science. And I guess there is also a third way now, people who graduate from universities and become data scientists immediately, right?
Yeah.
I think this is also a thing right now. So many people, for them, data science is the first job. I guess for those who are software engineers and they became data scientists, it's not that difficult to then transition to data engineering, because they already have all the skills. They know how to use terminal properly, they know Bash, they know Linux, they know CI/CD, all these things that are needed for data engineer,
Yeah.
right? But what about these who are coming from academia, or these for who data science is their first job? Like, how can they actually level up their software engineering skills? Like, do you know if there is a good course about that somewhere?
Yeah, there are good courses about this. I mean, DataCamp is not really recommended anymore for various reasons, but that used to be my go-to place because they had a really good software engineering track. But there are there are online courses that focus, and I would always recommend for a data scientist who wants to level up on programming skills to take one of those intro to software engineering courses. And even if it's web development or something totally unrelated that they're not really that interested in, but something that's not geared at data scientists, because in the programming for data scientist courses, they usually don't learn the software engineering fundamentals, but something that's more of a track to become a web developer or an Android developer even, or something like that. They usually teach the software engineering fundamentals in those courses. So I would recommend to try that. And it's always useful if you can build a small web app or if you can build a small Android app. It's not a wasted skill. And that's maybe a better way to find out if you're interested in these kind of things than to purely focus on your Python skills and learning yet another deep learning library.
Yeah, so what do you think a good course should contain? What kind of things? So I guess build tools, right? Like how exactly you build your software, right? And testing, CI/CD, command line basics, like how do you navigate, I don't know, Linux, how do you use Linux, right? Bash. Is there something else that you would say is fundamental for all software engineers?
Two things, Git, which you probably included somewhere in build tools, but it's worth pointing out separately. Docker is really useful. Right. And that may be a separate course in many cases, but it's definitely a really valuable skill. And then the whole idea of just collaborative coding or clean coding. So what are the best practices on how you structure your code with functions and objects or modules, these kind of things? How do you comment? How much do you comment? All these things that software engineers like to pull their hair out and get into into holy wars about, but that are worth understanding. How many lines of code should be in a function? All these kind of questions that are really useful to get a sense for, even if you're never engaged in the holy wars.
Yeah, so how many lines of code should be there in a function?
Less than a screen. That's my answer.
Less than a screen. Okay. So I remember reading this clean code book from Robert Martin.
Yeah.
I think his recommendation was like 8 lines or something like this.
Yeah,
which is
7 or
drastic,
8.
Right?
Exactly. Just enough to have a full if then else statement in there. That was his recommendation.
So basically you have a function declaration, then just a few lines, and then you have return, and then
I mean, he proposes doing heavy nesting of your functions, so that every line is pretty much a function call until you have your really small function, really strong decomposition, which has its benefits and drawbacks. But yeah.
Do you think it's a good book nowadays to read? It's pretty old, right? It's more than 12 years old.
And it's very Java-centric. Unfortunately, I've not found a better book. I still keep thinking somebody should write a better book, a more modern book about it, and maybe also something with maybe a person that's less controversial nowadays for their politics. But the book, unfortunately, there's still nothing really that I still recommend it, even though I have a lot of pains about it, because it's still, unfortunately, as far as I'm aware, the best thing we have.
Even though it's Java, right? I remember for me, I started as a Java developer, and for me it was eye-opening. So I also recommend this book to people, but I realized that now I guess maybe that's another question. Do you think, so what kind of languages do we need for data engineering? Is Python enough, or we need to go with Java and Scala and, I don't know, perhaps other languages?
So again, it really depends on what kind of branch of data engineering you want to go into. If you go into the more analytics engineering, which I would recommend to data scientists to at least try out first, then SQL and Python is often enough. Sometimes you may need Java, depending on what scheduler you're using. But usually you can go very far with Python and Java and Java, no, Python and SQL, and maybe JavaScript, but JavaScript as a third, low-ranking third option. But if you want to move into the whole Kafka and real-time streaming and distributed systems branch of data engineering, then yeah, Scala and Java, I guess, are unavoidable. And I'm not saying they're terrible, even though I don't really like both languages, but it's just my personal preferences. They're actually really good languages for if you dig into them. I've done a lot of Java development and a fair amount of Scala development in my life, but I'm kind of glad I don't do either right now.
That's also same for me. Well, at least for Scala, I don't know. Like it's too many ways of doing the same thing, and not all of them are obvious, let's say, to read at least.
Yeah.
Why JavaScript though? Like, why you recommend to learn JavaScript?
It's becoming more of an backend language as well, and so JavaScript is kind of emerging as a general purpose language in a way that Python always aspires to be, but never quite made it because it doesn't have a front-end component really to the same degree. And so there is tooling also in the no-code space, and so for instance, that relies on JavaScript as a scripting language. So it's useful to know, but as a really low-ranking third cousin, I wouldn't give it a high priority that the other languages have. But it's useful to know just to be able to read it and say, read an obscure lambda function that was written in JavaScript that your colleagues wrote, and be able to see where you have to maybe modify it, or at least talk to them where you need to modify it.
Yeah, and I guess the reasons that these obscure JavaScript functions exist is because when you Google something, when you try to look something up, often the examples are in Python or JavaScript.
Yeah.
And then when I see an example in JavaScript and I need to do something quickly, I just copy paste, I check that it works, and then I forget about this until it stops working.
Exactly.
Yeah.
And I think even in BigQuery, for instance, there's the UDF, the default UDF language, so user-defined function language is JavaScript. So
there is no Python support, is there?
I haven't seen it. No, I think we had to write all our UDFs in JavaScript for some reason. So it's pretty,
probably.
JavaScript pops up at the weirdest places, and that's why it's useful to know.
Yeah, probably Google wanted to have broader coverage, right? And I don't know what's the latest status, but I think if you take software engineers in general, people who know how to code, probably there are more people who know JavaScript than Python, right?
Definitely, yeah.
Perhaps. Then it just gives a wider coverage to Google, to BigQuery.
Yeah.
Okay. What do you think was the easiest part of your transition?
The easiest part of the transition was how much demand there was for data engineering. And I think that still holds. So even if you're not the greatest data engineer, when you're starting out, people will still get really excited about the fact that you exist and that you apply to their company. And it's very easy to find a job in data engineering. So it's not super competitive, which is a good thing when you're starting out, because it also has its drawbacks, because you can easily find yourself in a situation where you're way overwhelmed and expected to do things that you aren't ready for, and where you don't have good mentoring in place that can help you in your job, because there may not be enough senior or experienced people around that can help you with what you're doing. But the easiest part is definitely, just give yourself the title of data engineer, and your LinkedIn profile, your LinkedIn books will explode. So
interesting. I observed a similar thing, not with data engineers though, with infrastructure engineers. So we call them site reliability engineers, but other names are DevOps engineers. So people who take care of infrastructure. And it's super difficult to find these people. So when we open a position for data science, in one day we have 100, 200 applications, 300. Like in a week, it's a lot. So our recruiters just close the position after a couple of days. Right. But when it comes to site reliability engineers, we open a position and nobody applies. The second day, maybe one person applies, and then the third day, again, nobody. So they need to reach out to people. They need to actively reach out to people on LinkedIn and ask them, hey, consider our position. So I guess to some extent it also applies to data engineers, right? So it's not as because I think still data science is has this marketing thing, like you know, the success job of the 21st century, and people get excited, and everyone wants to do that. But I think data engineering is also getting some traction, right? So now people like you, they realize that it's not what they want to do. Then the people also see the demand for data engineers. There are also I saw quite a few posts on the internet, like on Hacker News, on Reddit also, that are quite, so the title is "You don't need data scientists, you need data engineers." You probably saw them as well, right?
No, I did not actually, but
but yeah, this is the type of content that people on Hacker News usually like. It's very controversial, and yeah, so that's interesting. What was the most difficult part for you of the transition?
Yeah, the most difficult part for me was losing some of the autonomy I had as a data scientist, and then having to work in these really close, tight-knit software engineering teams. And so I was very used to having a lot of space and working the way I wanted to, and not worrying too much about other people in my space other than my stakeholders. And I knew how to work with them, but I was not familiar on how working with other software engineers that much anymore. At least I hadn't done it in a long time. And so when I got hired as a senior data engineer, things were expected of me that I had never done before in terms of collaboration and in terms of leadership, and leveling up on those was quite hard, because that's not something that you just pick up by reading a blog post. But that was really a very different way of working, and not even understanding what was expected of me, because the people I worked with weren't used to working with data scientists, so they didn't know what to expect of me either. And then there was this whole mismatch of expectations on both sides, and I figured it out, but it was hard.
Can you maybe give an example? Is it like, I don't know, setting some, like the way you do things, picking up some frameworks, or what exactly do you mean by this leadership?
Yeah, it wasn't technical skills at all. So I could pick up the tooling. I had worked most of it with it before, and I could pick up what was missing easily. It was more around like, how do I communicate? When do I communicate? How do I pair with people? Pairing was probably the hardest part for me to learn, because I had never done that before. And ThoughtWorks were
like pair programming, right?
Yeah, programming, yes. Where work was really heavy on emphasizing pair programming, but also this whole sharing. It mainly just boiled down to sharing my thoughts and asking when to ask for help, to asking when to offer help, and all these kind of small things that I wasn't used to working mostly by myself before. So really how to work very closely with people on a day-to-day level, keeping them in the loop, knowing when to figure out when I need to get myself into the loop, and all these kind of questions.
So you would say that data engineering is more of a team sport than data science.
Exactly.
And engineering in general, I guess, right? Because usually you have a lot more engineers than data scientists. So maybe for a team, you maybe have one data scientist and then a bunch of backend engineers, right?
Exactly. And you usually have also more data engineers than data scientists, and so there's a whole different approach to working together.
In your experience, do data engineers usually work like in one team? So maybe there is one platform or data engineering team, or they are spread across different teams?
I've seen both. I prefer the model where there's not a data engineering platform team. I think unless you have a really large company where you really need a data platform infrastructure and you need people dedicated to that. I think in the smaller companies I've usually worked with, I think it works better if the data engineers are embedded with either with the other data folks, or also as part of a wider platform team. But for what I've usually worked with is these kind of embedded into a more general data teams that are consisting of analysts and data engineers and data scientists and maybe ML engineers and all sorts of data specialists.
And in this setup, you usually see more engineers than data scientists, right? More data engineers.
Yes, usually, but there can also be a lot of analysts, for example. That's common to see. So it depends on the setup.
Okay, there is a question. So do you know if there is a name for the role for people who are both data engineers and data scientists? Is such a thing? Does such a thing exist at all? Or?
I've not encountered it as such, but I think the closest I've seen is really analytics engineer. This particular, and it depends on what you consider a data scientist to be and a data engineer, because the overlap might be all sorts of things. It could also be, if it goes to the end, it could also be an MLOps engineer, for example. That could also be an intersection between a data engineer and a data scientist. So there is a bunch of titles, but it really depends, and maybe the person could clarify a bit. It really depends on what you're doing as in this intersection.
I think as a data scientist, at least I needed to do a lot of data engineering, because the data is not just magically a CSV file that you can use that is clean. Yeah. You need to do a lot of work before you can put this into a machine learning model and train your model. And for me, I even needed to set up like a workflow scheduler and do all that. I think in startups it's pretty common that they hire a data scientist, and then it turns out that this data scientist actually needs to do data engineering work before they can start with data science.
Yeah.
I also saw a title in LinkedIn. Some people put this title. The title is data science engineer. I don't know how common it is, and if it's a thing or they just decided to, because this is how they felt, and they put it there. I don't think it's a common thing, right? Like data science engineer.
I've seen that too, but yeah, I haven't seen it in job description. I've only seen it in people's profiles.
Yeah. So probably people who ended up doing data stuff, even though they were hired as data scientists.
Yeah.
That's probably okay. And so Chetna is asking if you have any tips for people who do not have development experience. How can they transition to data engineering? I think we talked about that already, like picking up all these skills. Like general engineering skills.
Exactly.
I think it was build tools, testing, CI/CD, Git, Docker, clean coding, command line testing. Is there anything else?
Yeah, I would especially if you don't have software engineering experience, I would recommend just doing toy projects on the side. So that's very common for software engineers to do that. They just build something random that they either think is fun or useful, and find some friends to do it together with, because that makes a big difference if you're not just working by yourself, but if you're really working with 2-3 other people. It can be something, pick something that you really find fun. So for instance, I build a lot of Twitter automation thingies back when I was trying to get into data engineering, and I didn't use any of the skills I learned about Twitter and Twitter analysis at the time, but it was really useful to deal with annoying things like OAuths and figuring out how that works and using Git properly and all these kind of things. So if you have the time, and not everybody has the luxury to have that kind of time, but if you do, it's really helpful.
What was one of the tools? Maybe can you give us an example? Is it like pulling data from Twitter for doing some analytics or something else?
Back then, that was a while ago, and that was before Cambridge Analytica, but I read the papers that Cambridge Analytica was based on, because Michał Kosinski papers from the Cambridge University. And he did a lot of identifying big 5 profiles out of Twitter data. And since I was a psychology student at the time, I wanted to see if I could replicate it. So I pulled data from Twitter and turned it into a visualization. I was supposed to turn into a visualization of the big 5 features as a web app. We never finished that thing, but that's kind of the direction we wanted to be going.
Okay, yeah, thanks. So, question from Hari. I am currently in the same situation. I am a data scientist. I want to move into data engineering. Would you recommend doing projects depicting real-life data engineering tasks? And do you think it would help in getting jobs? Yeah, I think the short answer is yes, but maybe you can also give a longer answer, like what kind of projects in addition to what we just discussed, like pulling data from Twitter. What else can data scientists do to move into data engineering? What kind of type projects that they can do?
Yeah, generally, especially if you do side projects, I think it's really helpful to not think what is the most marketable, but really what is the most fun to you, because you need to keep up your motivation for a while. And usually that comes if you do build something that's interesting to you, even if it may not be the most marketable thing. But for instance, what I've seen a friend build is he built that was when the pandemic was fairly fresh. He had a biology and computational biology background. He wanted to help with identifying genetic markers for vaccines. So that, as you can see, that was a while ago. And so he got some data sets around with the COVID genome and some other genomes. And then he built a whole ML pipeline and data engineering pipeline around extracting that data and building it up with CI tools and understanding the data, translating it into different formats and extracting the genome data and re-encoding it. I didn't understand the biology part of it, so I can only give a very bad representation, but that was kind of what he did, and I thought it was pretty cool.
Mm-hmm. One recommendation I usually give when people ask me, like, how can I learn more about building data pipelines, or if I'm a data scientist, and I usually suggest to build a scraper. Like, let's say, let's say we want to build a model for predicting the price of, I don't know, an apartment or a car, right? We have a lot of websites that sell cars or that where you can find apartments. Yeah. So you can set a scraper that every day goes to these websites, pulls the data from there, puts them in a, I don't know, a CSV file, and then puts them in a cloud, and then you can schedule it with Airflow, so you can have multiple steps there. And the first step, the actual scraper that would go there, pull the data there. Then the other step is, okay, now you have the pages, like now you need to process these pages somehow, right? And then you extract, you parse this data. And then the other step would maybe put this in a CSV file, right? So then you have a CSV file in your S3 or Google Cloud or whatever cloud you use. And I think it's important here to use a cloud and to use tools like Airflow or other schedulers. And then one of the steps there could be taking all this data and then training your model. So then here it's not just a CSV file that you download from Kaggle and train your model, but you have well, still it's a toy pipeline, but you have a pipeline that you schedule, that you run every day, and that you can use to actually, you know, learn all these things, learn Airflow or whatever other schedule. Do you know maybe other similar projects? If something comes to mind?
Not really, no. But again, I think it's I think the general approach that you described is really good about like building a real life pipeline with following whatever best practices are, but really I would reiterate the point, pick some data that you find interesting. That was probably the best advice I've been given by an experienced data scientist when I got interested in the space was, and I asked her about recommendation for toy projects. She really recommended me to pick a data set that I really wanted to find something out about. And I think the same applies to if you build a data engineering pipeline, build it for something where you actually care about the outcome. You won't always have the luxury at work. Sometimes you build data pipeline for data you're really not interested in. So at least when you're doing it in your spare time, care about the data.
And this example I saw a blog post on LinkedIn about somebody who was looking for a flat in Berlin, which is not very easy these days. So what they did is they also built a scraper, and they would look, they will find, okay, where are the flats that you know, basically first they get all the data, and then they see the flats with the price they are interested in, the areas, the neighborhoods they are interested in, and they look at flats that stay there for a while. And this way, like, they used this need, so they had a need to find a flat, and based on that, they built this pipeline, for scraping pipeline, and it helped them to find a flat in Berlin.
Yeah, that's awesome. That's a really cool project.
I don't know, maybe it's a bit off topic. The question from Bram is, most cloud platforms' data processing cost structures are not really transparent. Do you have any suggestion to manage data processing costs? I guess this is also important when you learn to use these things? So do you have any suggestions?
I'm not sure I would agree that they're not transparent, because usually the cloud providers provide very, very detailed billing information if you dig into the billing console. And yeah, that's definitely, especially if you have your side project, you can easily burn a lot of money if you don't shut up your EC2 instances and they keep running or whatever you might be doing. So yeah, my recommendation is most pragmatic recommendation is all cloud platforms have a budgeting alert function. So if you want to manage your costs, find out where you can get an email and get a warning for whatever half of the money that you're willing to spend or a quarter of the money that you want to spend, so that you get pinged on email. Mm-hmm. And other than that, really dig into the billing console, because there's a wealth of information in there, and you can drill it down to really nitty-gritty details on what exactly you're spending on each processing cycle of your Airflow cluster, and that information is there. But yeah, it's a bit of a science in itself to dig into that information. And maybe a good data analysis project just to figure out how to extract what you're interested in from your billing reports.
Yeah, you can pull this data, right? And then you have another pipeline to practice, right?
Exactly. You can build a pipeline. It's very meta. You can build a pipeline about your pipeline costs.
And I don't think this is a thing in AWS, but in Google Cloud you have this trial period where they're not charging you any money in the first couple of months. So they give you some money, some free credits, and then you can do whatever you want. And if you run out of these free credits, they do not start charging you. So they send you a mail saying, hey, you run out of credits. Do you want to upgrade or not? So it's a pretty safe environment to learn things there. In AWS, I don't think it's the case. They have free tier, but some things are part of free tier, some things are not. And then if something is not a part of free tier, then you need to spend money on that, and then you need to be careful. Let's say if you spin up a Kubernetes cluster or something like that, and you need to be careful that once you've done whatever you wanted, turn it off, right? Else you'll get a bill at the end of the month which you will not like.
Exactly.
But I think support is pretty good. So some of the students had these problems, so they forgot to shut down a SageMaker instance with a GPU, which is quite expensive.
Yeah.
And then they just wrote to support saying, "Hey, I accidentally forgot to do this. Would you be so kind to just remove that?" And then they actually did. So they said, "Okay, yeah, things happen." Okay. Other questions. In your perspective, what amount of project experience would we need or should we get to start applying for entry-level roles in the industry?
That's a very generic question. It would have helped if it was a bit so for data engineering.
Yeah, let's imagine that a student is a general, software engineering. So they probably learn data structure, algorithms, programming, so they know that. I think now graduates also know SQL. They learn SQL at university. So now they want to start working as data engineers. What do they need to do?
Especially if you have a relevant background in studies, I would always recommend to go directly for the entry-level positions, because I'm not a fan of people who have a full degree and then starting to get into unpaid internships or doing a lot of side projects just to get into, and that may happen to career changes, unfortunately, quite a bit. But if you have a relevant degree, then definitely try for the entry-level positions directly, and you will have done enough coursework and enough projects in university to be employable. And not every company offers entry-level positions in data engineering, but those that do, they will be prepared for graduates. Or if you graduate from a bootcamp or something like that, then I would also directly aim for trying to get. And if you don't have a relevant degree, but you have some other degree, then try to not do so much projects in your spare time, but try to get internships. because that will be a lot more relevant in terms of the experience you get quickly rather than just trying to motivate yourself. I've seen people that have purely graduated from their own projects, but those were usually unusually driven. I've seen a lot more people fail with that approach than I've seen people succeed.
And yeah, you mentioned one thing, that there are not so many entry-level positions for data engineering, and I think it's true, because usually, at least this is my perception, that for data engineering, companies want to see experienced people. So people who are perhaps, as you mentioned, especially this is if you're talking about Kafka and things like that, so they already need to have solid software engineering experience, know a bit of distributing system before they can be hired in these positions. Do you think it's the case? Let's say there are not so many entry-level positions. Would it be a good idea for people who graduate from university to first work as a backend engineer before they start working as a data engineer?
That's a really good question. So I think it used to be that pretty much every position that I've seen for data engineering was at least mid-level, if not senior, because that's when companies started out with building their data engineering teams. I think that's changing now. I think they're increasingly more entry-level positions, but it depends on the type of company. So as an entry level, I would always recommend, if you unless you're really confident in your skills, or maybe you want to found your own thing, that's an exception. But otherwise, I would really recommend to start up in either a consultancy or a larger company that already has an established data engineering department. So for instance, I worked a lot in my life in agencies and consultancies, and those were always really career accelerators for me. And I've seen the same happen for people that work in the big tech companies, and say Zalando or Delivery Hero, or these big Berlin companies, or whatever the local equivalent might be. Those tend to be career accelerators because you have a really well-structured learning environment. Usually in those, they have enough seniors, but they're prepared to take on juniors. And they're prepared to mentor and develop their juniors. It's very hard if you're starting out and and I've seen that also quite frequently. If you're a junior and you get hired as the first junior somewhere, and there may not be a senior around, and they just expect you to start. It sounds really exciting, but in most cases I've seen that happen. It was a recipe for frustration on all sides and a stalled career.
Interesting. So these consultancies are career accelerators, I guess, because they want to have a lot of, let's say you have a client, right? And I imagine that there are not enough seniors to work with all these clients, right?
Exactly.
So that's why they have this training in place to take this lot of seniors and put them on juniors. That's why they want the juniors to be ready to do the work as fast as possible, right? And then you have many projects that you need to move between one project to another. That's why you get to see a lot of different things, right?
That, and also it's a very financial thing. So a junior simply costs less, but to the consultancy, so there's a big financial incentive for them to have this pyramid structure where they have a few seniors that do the architectural work and mentor the juniors, but then the bread and butter work is usually done by juniors. And so consultancies most of them have their business model around up-leveling juniors. So that is actually so a lot of them have structured entry-level programs, and then there's a lot of expectations around mentoring, and that's ingrained into the culture.
Yeah, thanks. Maybe the last one. So if somebody wants to learn cloud, should they go with AWS, Google Cloud Platform, or Azure, or something else?
I don't think it matters that much, because they're all very similar actually. And if you know your way around one cloud, you easily find your way around the next cloud. That has at least been my experience. So find the one that's used at your company and get really comfortable with it and dig deep into it and learn all the functions that you can get a hold of. Or find the one that has the best free tier option that's relevant to you, and just learn that one.
And I guess another option would be in your city or in your country, look at what is the most common one, most popular one. So for example, in Berlin, I think if I look at job descriptions, I think AWS is more popular than Google Cloud.
Yeah.
So maybe if you're in Berlin, then going with AWS makes more sense. But I've heard that in other cities in Germany, maybe Azure is more popular than AWS.
It depends on the sector of the industry you're working in. So a lot of startups use GCP because they have very generous startups offerings. So for instance, we hardly pay anything for our Google Cloud offerings. A lot of larger tech companies, so more established tech companies that are not traditional enterprises, but are grown and mature startups, a lot of them use AWS. And in Germany, a lot of the enterprisey companies use Azure. So it really depends on which branch of the industry you want to be, or you have to be working in.
Okay, thanks. So before we finish, how can people find you if they have questions? LinkedIn, Twitter?
Yeah, either way works. So I don't know, is there a way you can share my contacts with them?
Yes, I will put this in the description.
Cool, yeah, so I can just share my Twitter and my LinkedIn profile with you, and then they can. I'm happy to, if people want to get in touch.
Okay, then I guess that's it. So thanks a lot for joining us today. Thanks a lot for sharing your experience. Thanks everyone for joining us and watching this, for asking questions. And yeah, that would be it.
Thank you. That was really fun. I really enjoyed this conversation.
Yes.